Hello everyone, myself Pavani, Assistant Professor in IT Department at SMIT. We are going to see about the network security. Subject code is CCS 354. Now moving on to IEEE 802.1x is a code-based access control protocol. It provides authentication for devices, works with wired and wireless networks. It uses EAP for authentication, involves three main components. Supplicants request network access. Authenticator controls the port. Authentication server verifies credential. It enhances enterprise security. Actually, this IEEE 80.1x is most important. It is the standard to authenticate devices before allowing them to access wired or wireless networks. It's widely used in enterprise LANs, Wi-Fi network, NAC systems. Let me define you. This provides authentication for devices trying to connect to a LAN or WLAN before granting access. Its purpose is to prevent unauthorized network access, authenticate user and devices, works with EAP method. Improve enterprise network security. It has three components: supplicant, authenticator, and then authentication server. Supplicant nothing but client device requesting access. Example, laptop, mobile phones. Authenticator, it's network device controlling access. Example, switch or wireless access point. And then authentication server, usually a radius server, verifies credential. And then it works under step by step. It has 8 steps. Let me tell you. First one, client connects to switch or AP. Port remains in unauthorized state. And then authenticator sends authentication request. Client respond using extensible authentication protocol. Authenticator forward request to radius server. Server validates credential. If successful, port becomes authorized. And then at last, network access is granted. Now moving on to 802.1x architecture. See, supplicant is this client device. Authenticator is usually a switch or access point. Authentication server is typically radius. Communication occurs using EAP over LAN. Unauthorized devices are blocked. Ports remain closed until authentication. Secure communication begins after approval. Locks track authentication attempts. It ensures control network entry. It's nothing but is a set of protocol used to secure communication at network layer of the OSI model. It provides secure data transmission over IP networks such as the internet. Let me define it. It shows that provides authentication, integrity, encryption of IP packets to ensure secure communication over insecure networks. It provides Internet Protocol security, which support confidentiality, integrity, authentication, and anti-replay protection. There are two main components. One is authentication header, second one is encapsulation security protocol. And then they have two modes of operation. One is transport mode, another one is tunnel mode. Transport mode, which encrypts only of the payload. IP header remains unchanged, used for host-to-host communication. Tunnel mode encrypts entire IP packets, add a new IP header, and use in VPNs. Key management for this it uses security association, internet key exchange, and then it has architecture database. One is security policy database, another one is security association database. And then we are going to see about the IP security overview. IP security secures IP communication. It protects data at the network layer, provides confidentiality and integrity, authenticate communicating parties, works in tunnel and transport mode, encrypts IP packets, widely using VPNs, prevents packet tampering, ensures secure communication over public networks. Thank you.